Thank you.
Yeah, so hello everyone. Thank you for joining DataCon LA 2020. Welcome to Data Engineering track, and soon we'll be listening to Data Versioning. Does it mean what we think it means? Session with Ainat All. I'm Navina, your host, and our co-host today is Jitesh. We'll be moderating the chat and Q&A for you during this session. Our speaker, Ainat, is a co-founder and CEO at Reverse. So now, without further ado, I'll hand this over to the speaker.
Hi, everyone. So data versioning, let's agree what it means, and then we can discuss if it means what we think it means. So data versioning is the ability to have a data set that is versioned over time. It is the same data set, but it evolves, and we have different versions for it over time, and we can usually time travel between those versions, go back to versions of the same data from the past. So why are we going to spend 40 minutes talking about data versioning and what it means? Because apparently data is something with context. It depends on who's using it and how. And then data versioning suddenly becomes this complex thing that is not just this basic ability that we all agree on. So let's see what I mean when I ask you guys if it means what you think it means. So just a short introduction about myself. I have a PhD in mathematics, which means my hands-on career revolved around algorithm development when it was still called that, what is usually referred to as data science today. I've managed a lot of pretty big data sets trying to run algorithms through them. And then I started managing people who do that. I was previously 4 times the CTO and VP R&D of Israeli startup companies, the last of which is SimilarWeb. You're probably familiar with it, but it is no doubt a data company. Its product is actually providing data about the behavior of people throughout the web and the applications world. And a year ago, I founded a company together with someone who actually worked with me at SimilarWeb, and it is called Reverse, and we are the creators of the open source project lakeFS that I will be mentioning in this talk as one of the tools that allows data versioning. So this is very briefly me. The more interesting question is, why did I become interested in data versioning? So I actually had a use case and I thought I needed data versioning for that use case. I'll tell you all about it later. And then I started looking for tools who actually provide data versioning, because you don't need to invent the wheel. If someone's already providing you the ability, you can just enjoy it. And I found a world of tools that offer data versioning that were very, very different from one another. And at the end of the day, none of them actually provided me with the needs that I had. So I thought it was an interesting thing to talk about. So we will talk a little about when it happened and this world of tools that exists that claim, among other things, that they do data versioning. And then we will cluster them to 4 different clusters. One would be managing machine learning pipelines. The other would be collaborating over the data. The third would be mutability. And I know it sounds strange, but when I'll give you the context, you'll understand immediately why mutability is the thing. And the last is the data lake manageability challenge. And once we go over all those clusters and define them, you can ask questions. If there isn't enough time for questions at the end, I encourage you to just approach me personally. I will be very happy to discuss anything you have in mind. So the world of data versioning, I think it started to become more popular around 2014. And slowly and safely, a lot of tools came to the world saying, again, among other things, that they provide data versioning, the way that we have defined it 3 minutes ago. And as I said, those tools are very different from one another in other aspects. So what we will do today is just take this world, which is really an example. There are very many other tools, but they are from the same kind. And I think those are the more high-profile tools. If I'm wrong, I'll be happy to hear from you about tools that I don't know about and that are interesting. But if I have forgotten someone important or neglected them, I apologize in advance and will be happy to add them to my clustering in the future. So this is the world of tools that I have encountered and researched. And since I realized the tools were very different and we're approaching either different people or using different technologies or different use cases, I thought it would be very helpful for me if I clustered them. So at first I thought I would cluster them according to the user. And I could find two very big clusters of users. One would be data engineers and the others would be data scientists. And if I clustered the tools according to the user, I would get two pretty distinct clusters, which is important, right? You don't want your clusters to be too overlapping. So they were distinct, but they were very big in a sense that two applications within the same cluster were really far from one another. So they had very little in common. And if you cluster things, they should have a lot in common if they are within the same cluster. So you would want clusters that are far from one another as much as possible and very dense. So the tools are very similar to one another. So user wasn't the right way to go. I tried clustering according to technology. That failed miserably. I just had tons of clusters with one or two tools or three at the most. And then I said to myself, okay, what would I be looking for? So clearly I am looking for a use case. I have a problem in mind that I'm trying to solve, and hence I am looking for a tool. So let's try and cluster the tools according to the use case. And that came out fine. I mean, it's not perfect, and we will see that in a minute, but it still gave me a very good idea of what's out there and what I should approach according to the problem that I'm trying to solve. And I thought that was useful, which is why I'm telling you that. So those would be my clusters. So without further ado, we can go into the use cases themselves. So the first use case is managing machine learning pipelines. There is this very wide world of ML ops tools. And those are the tools that assist us in managing our machine learning pipelines, starting with tagging the data and creating a learning set, throughout test sets, an environment where we can experiment and actually build our model, and then the ability to export this model into production, to pipeline the data into production, the real-time data usually into production, and get the model running in production, and then monitor the correctness or the quality of the model over time so that we can know when to retrain it, unless we retrain it all the time, which means we also have the ability or the tools to retrain the model all the time. So as you understand, this is a complex process, and such a complex process requires tools to manage it. So the first cluster would be an MLOps tool, which means it manages part of this long process I've just described, and also offers within the management of that part of the process, data versioning. So the context of the data versioning is the machine learning world. And out of this large group of icons that we saw at the beginning, this is the subset of tools that actually manage some of your machine learning pipeline and offer you with that the ability to manage and version your data sets. Whether it's MLflow or DVC, which is data version control, hint, hint. They're putting a lot of emphasis on data versioning. Pachyderm, that allows you to manage the DevOps of the entire process and also allows you data versioning, and also Datamo, Verta AI, and FloydHub, which is more focused on deep learning, but all offer, again, together with other capabilities, the ability to manage versioning of data. So where is the value of managing data versioning within an ML pipeline? This is a drawing I took from the DVC's website because it really illustrates very, very well what we're trying to version here. So a machine learning model is not only code, as we see in the upper row. It is also the data that is running with the code. This data could be, again, the learning set, the training set, the actual production data. And it is also the data that is produced when running the model or for running the model, metadata, hyperparameters optimization, and so on. And maybe some configuration of the environment as well. And all those three parts, the code, the data, and the configuration, are actually together building one entity, which is the model. And the entity that we want to version when we manage ML pipelines is our model. We want to have different versions over time of the model that we have built. And of course, the entire history or body of knowledge that assisted us in building this model that is an output of the three entities above. So this is actually what all those tools do in different stages of the machine learning pipeline. They allow the management of those three things together: the code, the data, and the configuration. Those could be versioned, as we said at the beginning, and you can time travel between the different versions. So the user is a data scientist, and the use case is machine learning management. So if you are a data scientist or a data engineer whose mission in life is to assist data scientists in doing a better job, you would be looking in this group. It means that you have realized that in order to do very good machine learning work, you would like to version the data, the underlying data that is used to identify, to create the models over time. And hence you would be choosing out of all the ML ops tools that allow you to manage data. And then the choice between the tools would be which part of the ML ops journey is most painful to you and you feel it is most needed to version the data. This would help you choose between the tools within this cluster. So this is a very clear, very good, dense cluster. And then alongside of it, there is this messy cluster called collaboration. There's only one messy cluster out of the four, but this is a cluster that is, although distinct from the other clusters, is a pretty big one. So the tools within it are very different from one another, but they all have one thing in common: they inspire collaboration. Not necessarily collaboration between data scientists, although this is a common use case within those tools, but it could be also data analysts, data engineers, or anyone, just business entities in the organization who consume data and want to collaborate over data. So the subset, again, from the first slide that we have seen, the subset of tools that are mainly around collaboration are Kaggle, Quilt, DoltHub. And just to explain more, I won't go into the details here. I've created this slide that kind of show you the spread of this cluster. So if I start on the right-hand side with DoltHub, again, one tool that represents a few of the possible tools in the cluster. It is the closest to the first cluster because DoltHub is all around machine learning and managing the data for ML models. It's just that it's really very much like GitHub in the sense that it wants people from all around the world to be working on the same model, trying to experiment together to build the best model they can, working on the same data, but also on the same hyperparameters and on the same learning set. They actually have a concept of a PR for data science. So you have a pull request, and the pull request includes not only code, it includes code, configuration and hyperparameters, and data. The whole thing is offered to the community that is working on the same project. So it's actually taking the ML ops tools we saw in the first cluster and adding on top of that a very strong layer of collaboration. A little less collaboration than that, but still offering collaboration, are tools like Kaggle. There are quite a few of those, and they offer data science models and also universal data sets that are versioned, but only in the sense that you can access them and use them, and not in the sense that you can physically collaborate over them like in DoltHub. But still allowing people to share knowledge is definitely collaboration, which is why those tools fall in this cluster. And going further away from our first cluster, but still very heavily on collaboration, we have tools in the like of DoltHub, again, one representative of 2 or 3 options that we saw in the logos. So DoltHub is not for machine learning. It's a database. It's a repository that allows you versioning of the data that you save within that database. They call themselves the real Git for data. And I get why they say that, because Git is a repository, right? We all manage code in a repository. So Dolt, and hence DoltHub, which is their managed service, is actually a repository where you save your data. Then of course you have to save it there, and you can't save it anywhere else. But once you do save it within their database, it allows you to manage versions and to time travel between versions of data, and all the niceties that you can get from a Git for data. Again, if you're willing to save your data with them. So also what it allows is actually to collaborate over the data very easily, because several people can change the same data set, commit data, merge data, and actually do Git-like abilities or Git-like actions on the data within DoltHub. So this is one cluster in the sense that its main use case is collaboration, but as you can see, collaborating can mean a lot of things depending on who wants to collaborate and how. So why would you go into this cluster and look for your right tool? It would be because you need to collaborate. You realize that you have a lot of problems because you don't have a good infrastructure to allow collaboration around data. And then according to the use case and the people who need to collaborate, you can choose a tool within this group. And then those people would be able to manage together their changes to the data. And just along the way, another thing that all those tools have in common is that they give you one access point to the data. Whether the data is saved within the tool or it's just an API to data saved on many systems in your organization, either way, it is one access point to all your data sets that allows or aspires collaboration. So this is our second cluster. Now we are moving more towards engineering. So the next 2 clusters are far apart from the first 2. And the first out of which is mutability. And it sounds a little strange. What does data versioning have to do with mutability? So let's just give the context that a lot of us are running data lakes over an object storage, such as S3 or Google Cloud Storage, in which case we live in an immutable world, and it is immutable in 2 senses. First of all, the storage itself is immutable. We save objects which are actually files, but once we save the file, we can either replace it or delete it completely. We cannot change it. So the environment is immutable. To add to that, or because of that, the data formats that are usually used within object storages have immutability of their own, whether it's Parquet or Avro or just CSVs. So we are putting our BI data into those data lakes that are actually object storages. We do that because it's cheap. We do that because the throughput is very high. It's a very good choice from an engineering perspective. But then we are faced with the fact that the environment is immutable. But our BI data is not immutable. And this is where the need for mutability comes in. And here are the solutions. So we are given 4 different data formats that allow mutability within this immutable environment. And this is what they have in common. And you must be asking yourselves, okay, so we have data formats, they allow mutability in an immutable world. What does that have to do with data versioning? So if we look a little into the implementation details, then we see that it has a lot to do with data versioning. Because how can you achieve mutability if your building blocks are immutable? So you save those files into the object storage. And in order to actually get evolution over time, you manage metadata over those files, over these formats that are immutable. And the metadata holds the ability to make changes. So we're going to save the first version of a table in a file. And then when we get changes, we would save them in a different file. And then either on write or more popular on read, we would just read all the data from those files and create one coherent view of the latest values of the data using the metadata we have accumulated together with the data. I hope I'm being clear, but in this process where we're saving data and then saving deltas of changes, we are clearly creating change over time. And hence it is a must in such a solution to have evolution over time that is versioned, and a byproduct of wanting mutability becomes the ability to actually have versions over time, and hence time travel within the data. This time travel in those solutions is usually short time, weeks or a month, or a short period of time, depending on the amount of data. Otherwise, you get performance issues. But it does allow time travel within the time that you decide to save the data or use the data. And so this is, as we saw, Iceberg, and Hudi and Delta Lake and ORC, all open source projects, and all providing actually the very similar capabilities that were offered originally by different organizations to the world, but do the same thing. So when would we be looking for this solution? So we would clearly be running our data lake or managing our data over an immutable environment such as S3, Google Cloud Storage, MinIO, any other object storage of your choice, HDFS. And you have structured data, which is running on a columnar format, usually Parquet, and you need mutability. So you would be needing mutability because BI data usually has backfills. So today we know something, but then the day after, suddenly someone fixes something in your Salesforce, which actually means you need to backfill your BI data and fix something. So there are updates to the data because of knowledge that comes in later. And another very popular use case of the last 2 years would be GDPR or other data compliance that requires you to sometimes delete data from your data set, which also requires mutability. There are other use cases, but those are the 2 main ones that make those formats more and more popular within data lakes. When you manage the data the way it is managed, along the way, you get concurrency, again, because of the versions and managing the deltas through metadata. And you also get ACID guarantees. You know what came in, when it came in, what came in first. All those tools assume a single writer, by the way, from Spark. So you get consistency, which is important when you run BI tables. And as we said, as we expect, you would get for the period where you manage the data in this manner, time travel within the different versions of the data that are kept. So now that we are in the data lake world, and we are talking about managing data in an object storage, this was actually my use case. So when I started looking for solutions for data versioning, I wasn't looking for assistance in our machine learning pipelines, although maybe I should have been looking there, but I wasn't. And I wasn't trying to solve a mutability problem. I was trying to solve for the mess. When you manage data on a data lake that is actually an object storage, you are basically managing a shared folder. And try managing petabytes of data and tens of users accessing the data when we all want to democratize the data within the organization, and try and do that.
Hi, Anat. Hi, Anat.
Yeah.
Sorry to interrupt. I just wanted to remind that we have 10 minutes before the session ends and to answer any questions that we have. Thank you.
Okay, so I'll just finish this section, which will probably take me 5 minutes. I'll try and do it quickly, and then we will have 5 minutes or a bit less for questions. But as I said, I'll gladly answer any questions that you have offline. Just feel free to approach me.
Sure. Thank you.
So we have, as I said, we're trying to solve for the mess, and we have our data lake on an object storage, and we are managing petabytes of data as a shared folder. So if someone accidentally, and the word accidentally is, you know, accidents happen. So if someone accidentally decides to save data with the name of a file that already exists, they would simply delete the older version. And coming back from that is possible if you did a few things before, but not easy and very time consuming. So the potential of a mess is very big, and I was looking for a solution to solve for the mess. And we couldn't find one. And this is where my co-founder actually decided that it would be a good idea to have a Git for data when we were looking to try and see which of the tools is actually the Git for data, but in a completely different sense than all the tools that we have just seen. Just in the sense that when we access S3 and we look at our data, we would like the ability to branch the data and to work in isolation and do everything in isolation. And we would like to be able to commit changes to the data on our own branch without anyone else looking at the data lake, being exposed to our changes. And of course, without us being exposed to the changes that are currently done to the data lake. So this is this is the gist of isolation. And isolation is so important when you work on a new ETL, or when you're trying to just upgrade a Spark version, or anything that you do on a data lake. So this is what we were looking for. We were looking for Git-like capabilities over the objects of our data lake. So why would you be using a solution like lakeFS? Why would you be looking at this cluster that I'm sure is going to grow over time, because this is a very urgent need for a lot of companies. So you manage your data over a data lake, object storage, and you want to create development environments. So you want your developers to be able to experiment in isolation, whatever they do, whether they do machine learning, whether they write ETLs, as I said, maybe because they want to upgrade a Spark version, and maybe because they want to try a new encryption algorithm for the data. Whatever they want to try, they should be able to easily do it in isolation. This is where you would be looking for a tool like lakeFS. You can just branch, get a snapshot of your data lake, and use it as a development environment. Once you are done testing, you can either discard the branch or you can commit your data, the new data that you have created, merge it into your master data lake and expose it to the world. Either way, the pipelining of the data is going to be very easy, and it is all atomic immediate actions. The second use case would be if you want to continuously integrate data into the lake. And the third would be if you want to continuously deploy data into the lake. In both cases, you have data that is coming in here in and needs to be ingested. And I'm really cutting it short, but you would want to ingest the data in isolation on a branch. You would want to test the data, either for format or for PII governance, or if it's your production data, for statistical characteristics it might need to have. And only when you decide the data is quality data will you be merging it and exposing it to your production users. So you have this break, just like we have with code. When we integrate code into our code repository, we have continuous integration that makes sure that the code is tested. And when we have continuous integration of our code into production as a feature, we have system tests running and making sure that that code is production ready. Think about the exact same concept, but when what you integrate is not code, it's data. And I'll stop here so you'll have at least 4 minutes for questions. So thank you very much for listening, and go ahead if there are any questions.
Thanks, Annette. This is an interesting topic. So, Jitesh, do we have any questions for Annette?
Not yet. No questions in the UHA yet.
Okay, cool. If anyone have doubts, you can reach out to Annette later. So Annette, like it's good to know about this data versioning. Like this session will definitely help us in gaining knowledge on different tools for data versioning and be able to compare and choose the right source.
Thank you very much.
One question, Annette, I have is, what's the downside, especially when you are dealing with large amounts of data here and trying to incorporate this data version? Do you see any? You briefly mentioned about like performance issues, just trying to understand further on what is that we need to watch for.
You're talking specifically about lakeFS or other tools?
lakeFS, yeah.
So lakeFS actually manages metadata. So it doesn't copy data, and it manages it in a very efficient way, which allows it to give very high performance. Even if we're talking about hundreds of millions of objects, and hence very many petabytes of data. So there is an onboarding process where we calculate all this metadata, and then we manage it very efficiently so that very large environments can enjoy the versioning without, of course, any copying or duplication of data, which is also a byproduct of the tool that really helps. Once you start using lakeFS, there is no need to copy data, and hence there is a small saving in cost. I mean, object storages are not that expensive, but if you have a lot of data, and in order to get isolation, people usually copy data. With lakeFS, they can just open a branch. They are not copying data. And only if they create new data will we be saving new data into the storage. We're not replacing the storage. The storage is still S3 or Google Cloud Storage or MinIO. We are just managing metadata over the storage in a very efficient way.
Got it. Thank you.
Okay, so we only have 1 minute left, and unfortunately, we'll have to end this session right now. So thank you, Annette, for your presentation, and I appreciate all the attendees for the questions and interactions during this session. Please contact the speaker if you have further questions regarding this topic. Please provide your comment and feedback to us or the organizers on the community board, or start a discussion there to connect with others in the DataCon LA 2020 community. Thank you for joining today's presentation, and I hope you can gain some insights from this session. Have a wonderful day, and thank you for being a part of this year's DataCon LA. Thank you.
Okay, thank you very much. Goodbye.
Yeah, thank you. Bye.
Thank you. Bye.